Here is another example about the law of conservation of energy and kinetic and potential energy. Please consider this problem on the board. We have a John. John works for a circus, and he climbed up this pole all the way to that bucket, which is some height h above the ground. And his potential energy at that height is 100 joules. He's just standing there, not moving. His kinetic energy is 0 joules. But in a second, he's going to jump down. So he's going to be flying down into a bucket full of water. And of course, he's done this before. He's going to survive. If we consider what's happening to the potential energy as he is falling down into the bucket of water, as his height is decreasing, that means that his gravitational potential energy also has to be decreasing. And his speed, of course, is getting faster and faster and faster. So we can say that the potential energy is being changed into the kinetic energy. But as a sum, if we consider the total of the potential and kinetic energy at any moment as he's falling, that sum has to be the same. So if the sum on the very top is 100 joules, then anywhere as he's falling down, the sum of the kinetic and potential energy has to be the same 100 joules. So for example, at this point right here, this would be exactly half the way down to the bucket. If his potential energy is now 50 joules, then his kinetic energy has to be whatever number. If I add it to 50, it has to be equal to 100. So it also has to be 50 joules. 50 joules. The energy doesn't just disappear somewhere. It doesn't go anywhere. It gets changed or transformed from one form to another. Now we're dealing just with two forms of energy. So if it's not in one, then it has to be in the other. And then if we look at the situation when he's down in the bucket on the ground, where his potential energy is 0 joules. So where did all of the potential, all those 100 joules, where did it go? Well, into the kinetic energy. So he is moving right before he hits the ground. He's moving very, very fast. How fast? So fast that his kinetic energy is now equal to 100 joules. 100 joules of kinetic energy right before he hits the ground, right before he hits the bucket.